Hey Kim Stars, we're back again with a new video. This is going to be 4-5, but first you must do a review of grams to moles. Remember, this goes on the left side of your grams to moles notes. And the beautiful thing is, I did you a little favor. You already have molar masses, so you shouldn't have to do that part of it. Okay? Hit pause. See you in the next one. All right, here we are, 4.5 moles to particles, page 28. So, yesterday, or the last time you watched a video, we went from grams to moles, or moles to grams. Now we're going to take that a step further, like how many little atoms of carbon are in 1 mole. That's what we're going to find out, and that's actually our first step right there. So this is moles to particles, and we're given what is called Avogadro's number. Avogadro's number tells us how many particles are in 1 mole of a substance. So this is how we can relate those all together. All right? So the equivalence statement is, and I can write down Avogadro's number for you, but you're going to see it in just a second, but 6.022 times 10 to the 23rd, and that's particles, right? The other thing is, it is on the back of your periodic table. If you look at the back of your periodic table on the bottom left-hand side, it says useful constants, and the first one is Avogadro's number in A, and it says 6.02 times 10 to the 23rd items per mole. So you can either use 6.02 or 6.022 times 10 to the 23rd. We also need our calculator for this, and it's going to be kind of a review on how to use our calculator with our exponents. All right, so particles, there are actually 3 different ways to label our particles. All right, we have ionic compounds, which is a metal and a non-metal, right? And we label those, that's not a highlighter, we label those with formula units. If we have a covalent compound, that's 2 nonmetals, we label those with molecules. And if we have a single element, we label it with atoms. All right? How to convert? It's very similar to what we just did. Again, it's about using this equivalence statement up here. 2 moles from particles, we multiply by Avogadro's number. 2 particles from moles, we divide by Avogadro's number. So let's kind of see how that works. We don't need anything about molar mass today. We just need our equivalence statement. And I'm going to go even bigger with this. All right? We need this equivalence statement right here. Okay, so it says how many moles are in 1.2 times 10 to the 24th molecules of water. So again, we're looking for moles, so I'm going to circle moles. And then we know we have 1.2 times 10 to the 24th molecules. So we start on our T-chart with what we know. So we're going to put 1.2 times 10 to the 24th molecules. All right. And then using Avogadro's statement, we know that 6.022 times 10 to the 23rd molecules equals 1 mole. And that can be of water. All right. So now we're ready to type this in. And this is where we need just a little bit of a review. All right. Remember to type this in. We're going to type in 1.2. And then we're going to use that E button, right? Or EE button, kind of depending on what type of calculator you're using. But it usually looks like an EE button, but it'll come up on your calculator with that capital E. And then you're going to say 24, because that E means times 10 to the. All right, 24. Then you're going to hit the divide sign. All right. And then you're going to type in 6.022. Missed my O, didn't I? 6.022 E23. And the answer you should come up with 1.99. There should be no exponent anywhere. If you got an exponent, you didn't type it in quite right. So try again. All right. Kind of follow exactly what I said there. All right. You should have gotten 1.99 moles. All right. Okay, let's try this again. Now this time it says how many moles, we're looking for moles again, are in 4.76 times 10 to the 22nd formula units. Woo, okie dokie. So Again, we're going to start with 4.76 because that's what's given to us in the problem. 22 formula units. You can abbreviate like form, un. All right. And we're going to divide by Avogadro's number. Again, form, un. All right. And then 1 mole on top. Form, uns canceled, just like molecules canceled up here. All right. And again, typing it in, following along, we got 4.76. Then we're going to hit E, not times, not anything like that. 22. Then you're going to hit divide. 6.022 E 23. And the answer you should get here should be less than 1. The answer you should get is 0.079. All right, and that's moles. Okay? Hopefully you're getting those okay. If not, please either email or ask the next time you're in class. That way we can make sure we're doing this correctly. Okay? Awesome. Now let's shift gears. This time we're going to go from moles, right? We have 0.5 moles of water, and we want to know how many molecules do we have. So again, 0.5 is what we're starting with. And we know that 1 mole equals 6.022 times 10 to the 23rd. And that's molecules in this case, since we have a covalent compound. And we're ready to calculate this. And again, multiply across the top. So we've got 0.5, and then we're going to take it times 6.022 E 23. And our answer that should give us 3.011, all right, times 10 to the 23rd. You should have like a times 10 to the 23rd or something else on there that signifies, like it might say E there, but you should have a 23rd there. All right, basically a half a mole has half the molecules. Okay, let's try one more. How many formula units? We're looking for formula units. And we have 3,000 moles. So on our T-chart, we're going to start with 3,000 moles. Then we put 1 mole down on the bottom. And we have 6.022 times 10 to the 23rd formula units. All right. Moles cancel. So we're going to take 3,000 times 6.022 E 23. And you should come up with, ooh, a big one, 1.81 times 10 to the 27th power, and that's labeled formula units. Okay, awesome. Put a little extra S on there, but it's okay. Take it out of there. Awesome. Hope that makes sense. See you next time.